All right, great. Welcome everyone at this late hour. My name's Robert Blumen. I'm a DevOps engineer at Salesforce. A big chunk of my work is writing code in Terraform. I want to share some things I learned migrating code base from Terraform 11 to Terraform 12 that I hope you'll be able to use in writing your Terraform code and making it better and easier to understand. I'm going to talk about some of the problems in Terraform 11 that you can solve with Terraform 12 and 13. Then I'm going to go through new features in Terraform 12 and 13 one by one and talk about what some of these features do. And then I'm going to wrap it up showing you how to put it all together to do something useful, improve your code. A lot of the problem in Terraform 11 is you have some kind of problem domain, which you may have a conceptual model of your domain. It's an entity relationship model, and you have associations. You organize it the way you understand the problem. And then you have a provider, and the provider has certain APIs which are highly normalized. You can create one resource at a time. And there isn't really a good way, Terraform 11, to get from the left side of this diagram to the right side. So what you end up with is the code is really dominated by the provider API. So your code looks like the provider API, and you lose track of what your problem domain is. So the reasons for this is Terraform 11 doesn't have a lot of stuff that we are used to in many programming languages like looping, especially nested loops, conditionals, data structures. It's relatively primitive language. So now I'm going to talk about some of these great features in Terraform 12 and 13 that make it possible to do a bunch of cool things. Terraform 12 has structured data types, and you can compose them into more complex data types. Terraform 12 will do type checking for you to ensure that you're passing the correct value into your data types. That is pretty useful because it will cause Terraform to fail if you have an error. Whereas Terraform 11, you often get quite far along, you get an error, and then you debug it and you find out it's a type mismatch. Here's an example. We have a list of type string, and it will insist that you only add strings to that list. Here's another little more involved example. The data type, it's a structured data type. There's two fields. There's this name type string and age, which type number. I'm assigning a value which is of the correct type, string in a number. And here I'm going to showing you I ran some Terraform. I use a /var flag to pass a value in on the command line of the correct type, and that worked. In this case, I have made a type error where I'm passing in a string. There should be a number. Oops, went too far. And then you see it tells you a number is required. So type checking. Another feature in Terraform 12, I don't know what the name of this feature is in Terraform 12. In the Python language, it's called splat. What splat does in Python is if you have a list and you want to pass the values in the list as arguments to a function, you splat the value and it maps the list elements one-to-one onto function arguments. In Terraform, you do this with this syntax. The merge function takes arguments which each argument must be a map, and it merges them into a merged map. So if you passed in local.groups without the ... it would take it as a single argument and the function would fail. The groups, it's a list of maps. So what I want to do is each map in the list to be treated as a single argument. Use a ... syntax, and here's a result we get as a merged map. We're gonna move on and talk about a number of features around collections and iteration. Terraform 12, there is a kind of iteration, so I exaggerated a bit when I said there's no iteration. You can use count. When you run the apply, it creates things that look like this. They're indexed. This is not great for a number of reasons. One is that you can't tell what number 0 or 1 is by looking at it. Another is if you remove something from the middle of the list, then Terraform will try to reorganize the list for you, and there can be race conditions where if it tries to add something before it's been removed, it could end up creating it twice, which can fail if there's a uniqueness constraint. The way Terraform 12 handles this is the for each attribute, which requires that you pass it a set. When it creates the objects have names which are members of a map, and that the resource itself is treated as a map. This is great because you could tell what the thing is. If you do a Terraform state list, you can tell what each thing is by the key of the map. And you can remove things because the elements of the map function in set semantics. You can remove something and there's no issue of ordering. So I could refer to a particular item if I wanted to do something else with that resource. This is what the old way looks like, the new way indexing. Another great thing with for each is that the value of the iteration is available to use in other resources. It's called each.value. In this case, I'm using it inside a string interpolation, but you could use that value anywhere in any resource. You can also iterate with for each, iterate over a map. Here I'm creating a map inline using for expression, which I'll have more to say about later. You don't have to create it inline. I just did it here. And we're iterating over the map with a map. Terraform makes available each.key and each.value. You can use those anywhere else in the resource for any other attribute. That turns out to be very useful. Now, I'm going to show how you can use this to make your code very compact. You can chain resources together using iteration over the previous resource. So I'm going to start out. I have some variable called groups, which I didn't show you. It's some groups. We're going to create an AWS IAM policy document called access by iterating over these groups. And then I'm going to chain it to an AWS IAM policy. And when I do that is I do a for each, and I pass in the previous resource, or in this case, a data element that I've already created. As far as Terraform is concerned, that data.AWS IAM policy document.access is a map. So I can iterate over it. And I have the key available within the access resource. And I'm going to use the key in the name. And then I'm going to chain it again to attach this policy to the group. And I'm going to do that by iterating over the second resource, which, as noted, a resource is a map, and you can iterate over it. And the policy ARN is, so each.value is the resource, and we can extract the attribute ARN from the resource. The group is each.key. How do I know that? Well, the key, each.key is the key in for each, which is the key of the map called access. And what is the key of the map called access? Well, it's the key of the policy document, which we go all the way back to the left, which is the group name. So I was able to create a series of related resources by chaining them together using the fact that each resource is a map and then iterating over the maps. Terraform 12, they introduced this for each, but it did not work for modules. Terraform 13, they added support for modules. When I was upgrading a lot of code to Terraform 12, I found that often I only created a module because in Terraform 11, I had to copy and paste so much code to do the same thing over and over again. And that when I chained everything together in the way that I showed here, that I ended up only needing to create each resource once, and I did not need a module in 80 or 90% of cases. Then there's the percent remaining in which I did want to reuse the same code in multiple places, and I did need a module. And there were a few cases where I could have used this for each support in module had it been available at that time. Moving on, next big feature set is set operations. There are functions available on sets, and you can use them to do some cool stuff that might not be immediately obvious. In this example, suppose I want to do one thing with some elements of a list and something else with other elements. So we have our groups, all groups, some groups, which is a subset of all groups, and now you can get the other distinct subset by using set subtract. So I'm going to create a group for all groups. When members of some group, I'm going to do one thing, and other groups, I'm going to do another thing. This is essentially if then else implemented using set functions. This is a way of getting a conditional behavior. Show you another cool thing you can do with conditionals. Very common, you have certain resources, you only want to create them in some environments. In this case, we have two test environments. We want to create this resource only in test environments. The other staging, production. I'm going to assume there is a var.environment, which contains the name of the environment. So I'm going to do a set intersection with this tiny set, which contains one element, which is var.environment with these test environments. Either I'll get back the same set containing the test environment if we're in a test environment. If we're not in a test environment, I'll get back an empty set and it won't create anything. Now you could kind of try to do something like this with a count and the Elvis operator in Terraform 11, but I'm not sure you could actually do this. This, I think, is better. It enables you to conditionally create things according to any criteria you could think of early. Next big add in Terraform 12, for expression operate on list and map data types. There's two kind of for expressions. There's the ones with the square braces in which you create a list. And you got on the left side of the colon, the iterator name and the set that you're starting from. And on the right side is what your result is. You have access to the iterator value, which in this case is u, the iterator variable. Then you got the map for expressions where you iterate over can be a set or a map, and you create a key and value pairs with this right arrow. What's on the left is the key, what's on the right is the arrow. You can put in if, so another way of getting a conditional behavior. You create a list and then you either add or you can either include or exclude certain values from the list, and then you can assign this list as the value of for each. You can also iterate over a map using a for expression. You get a key and a value. And in this case, I'm turning a map into a list using an interpolated string. One more thing you can do with these for expressions is group by, which uses the ... syntax. This is the same syntax that is used in that thing I was calling Python splat, but it means something different. What it means is group all the values having the same key into a list as one list value. So in this case, the key is the first character of a string. And there are two possible values in this list, A and D. So using that group by operator, it's grouped these into two lists, those strings starting with A, those strings starting with D. This will also turn out to be useful. Okay, up to this point, I'm showing you a lot of features, and you might say that's cool, or you might think, oh, I know something that I could use that for. And I'm going to talk about why this all, how do I think of these things in relation to making your code better. It's a very common case in a domain is you have a many-to-many association. Typical case would be users and groups. If a user could belong to more than one group, then it's many-to-many. Now, your provider API, typically it's a very normalized. You could create a user, a group, or a user associated to a group. So it's pretty easy to create the elements of the association of the two sides, but how do you associate them together? Particularly what goes here. I'm going to show you how to do this. So example from PagerDuty, users, teams, and team membership are in the provider. In a comparative programming language, I would use nested loop, do it this way. Terraform, I'm going to start out with data. It's organized according to how I perceive the domain. I have decided that I want to see the teams and then the members of each team. Another way you could organize this would be to list the users and which teams they belong to. This is going to depend on how you organize the information in your mind and what do you think are the cases that are more likely to change. So I've done it this way. Now, the teams, it's pretty easy. I'm going to call the keys function on on-call teams. If we back up, see on-call teams, it's a map, and the keys are the team names and the values are the team members. So call the keys. To get the users, it's a little harder. We're going to take the values. The values gives you a list of lists. We need to flatten that and then do a distinct to remove duplicates. And that gives us a unique list of users. We're going to create the users. And to create the association, we're going to use some of these cool things that I've been talking about previously. We're going to do create these pairs of team and users using a nested for loop. We're going to first outer loop is iterating over the map of teams and users, and then the inner for loop we're iterating over users, and then we create a structured data type consisting of user and team. Then I'm going to do another step where, so that's giving us, it's a two-level of nesting, it's giving us a list of lists of records. So I need to flatten that. And I'm going to use a for expression here, turning it into a map. The key, it turns out, doesn't matter really. It only has to be unique. So I'm going to put the team and the user in the key because I know each team and user pair is unique. And I'm putting the team ID and user D in another structured data type. Then to create the membership, I now can do a for each and iterate over this data structure I've created, the team and users. Like I said, the key isn't important, it's the value. So I get the team ID and the value ID out of the value and create the association. Another similar type case, if you have a provider which wants you to give one side of one-to-many or many-to-many, and you have it organized the opposite way, I believe in AWS IAM group membership that when you create a user, you can pass in a list of groups. But I don't have the groups that belong to user. What I have are the users who belong to a group. So I need to invert the whole thing to get the groups. So I'm going to do something really similar. The first section, it's a lot like the thing I did last time. And then I'm going to create this map called groups by user, where I use that grouping operator to get all the groups belonging to that user to be in a list. And now I can create the membership and oops, let's back up here because each dot key is the user and each dot value is the groups that user belong to. So what am I talking about here? I think this is a way that you can organize your code in Terraform 12, calling it data transformation resources. It's data driven. So you have your data and it's separate from your resources. You have your data and you can organize that using data types according to the way that you want to organize your data model of your domain in your mind for clear thinking and understanding. And then you're able to execute these transformations using set functions and for expressions in such a way that you transform the data into the normalized format that your provider wants. And then you create your resources one at a time, no copy paste. And it's really easy to change because when you're changing things, you go into your data model and you change your data and everything just ripples down. You don't have to go, when you make a change now, create more resources or remember to copy and paste any code. So the transformation features in Terraform 12 create this bridge between the problem domain structure and the provider APIs. I think if you follow this, you will find you have really minimized the amount of code you have to write, and it'll be much easier to make changes. So here's some summary points. I think I've already covered all these points. And so that's it for me. Thank you all.
Hey, Robert, thank you again for this wonderful talk. We've got a few questions in the chat, if you don't mind answering them. So the first one is, did you retrofit the new features in the old code or use them only in new Terraform scripts?
We migrated a ton of code from 11 to 12, and the 11 code had become a huge pain point because every time we had to change it, it just grew and grew and grew. And the code size really shrunk quite a lot, and getting maintenance benefits because it's easier now to continue to change the code that we have. I think if we had code that we never changed, we might or might not have left it, but we wanted to get on Terraform 12, so that was another reason.
Okay, assuming you have loops and workarounds in the old code or brutally unrolled copy-pasted loops?
Yeah, we had what you could, in retrospect, say were unrolled loops in Terraform 11. And we were able to get everything into this, everything or maybe 95% of things. I think when we went to 12, there might have been a couple of cases where we had a module where we couldn't inline it because we needed it in more than one place. And we would have used for each on the module had we had that available.
All right. Kind of going through this process, is there anything you would have done differently?
There is another part of this which I didn't talk about, of the migration steps from 11 to 12. I'm pretty happy with where we ended up, but you do have to be careful if you have state. And when you restructure from Terraform 11 to Terraform 12, it cannot in every case figure out, if you change the name of a variable, it can't figure out it's the same thing. So you have to migrate the state. There's all kinds of things that can go wrong with that. And you have to think pretty carefully about what you're doing before you do that.
Right on, that makes sense. Well, thank you again so much for joining us and sharing your story. I don't see additional questions, but if you'll join us on the YouTube chat, I would definitely appreciate it.
Will do. Thank you so much.
Thank you.